3.1. Chapter 3, we are talking about something called functions. You guys ever remember graphing lines and things like that? All of those are technically functions, okay? So we're actually going to define a function, so don't worry if you don't know what it is. But chapter 3 in general, we're going to be like graphing linear, like lines and doing things like that. This is when we start doing a lot of graphing. So some vocab. A relation is a function if each input has exactly one output. And it passes what we call the vertical, oh, I can't talk. The vertical, or right apparently, what is this? The vertical line test. Guys, my handwriting really deteriorated over the weekend. Right, so what does all this mean? All right, so a function is a relation if each input has exactly one output. Now, what does that mean? What's an input? What's an output? Well, when we're talking about like lines or equations and things like that, an input is simply your x value. You know how when you're doing, do you guys remember like y equals mx plus b? That's technically a function. So x's are the inputs and y is the output. Exactly, yes. So input, think you're like putting it into the equation. You plug in x, so that's your input, and then you simplify it and you solve for y. That's your output. You put in x, out comes y. And if it passes what we call the vertical line test, what that means is we're actually going to draw ourselves a little picture over here of what that looks like. So I'm going to draw a little xy axis. I'm actually going to draw two of them. They don't have to be beautiful, it's just to give you an idea. Okay. So when you are graphing something, there's a lot of different things a graph can look like, right? Sometimes they're straight lines, sometimes they curve around, right? But when, like visually, how can you tell if it's a function or not a function? That's what the vertical line test does. So let's say you had, I don't know, maybe like a little squiggly like this, okay? Like it goes up and then it comes down. Well, to know if this passes what we call the vertical line test, that means if you draw a vertical line through it, it's only going to go through your picture one time. So if I drew a vertical line anywhere through this, is it only going to touch my graph one time? Yeah, it doesn't matter if I draw it all the way on the left or somewhere in the middle or somewhere on the right, it's only going to go through it once. So this would pass the vertical line test. Yes, this is a function. So what's something that wouldn't pass the vertical line test? Perfect. I like it. A circle. Yeah, a graph can be a circle. There you can actually graph a circle. You don't in this class, but like in Algebra 2 you do. So if I drew a vertical line through this, isn't that going to go through my graph twice? So that means that would not pass the vertical line test. Okay, so this one, if I asked you, you would say this top one, this is a function. But this bottom one, this is not a function. Except I can't write like that on here. Do it over here. Not a function. Okay. All right. Then we have a little thing called domain and range. Have you guys heard of domain and range before? It's probably something we've like heard the word, but maybe don't remember how to find it, and that's okay. The domain is all the possible input values of a function, or in other words, it's all your possible x's. That means anywhere along your x-axis where your graph can reach, that's part of its domain. Range is all the possible output values. Or in other words, all the possible y's. That means anywhere, so you know how like if you have your x and y axis, the x-axis goes left to right, okay? The y-axis is up and down. So your domain is anywhere your graph can stretch from left to right. The range is anywhere it can stretch top to bottom. Okay. And we'll talk about, I'll show you how to find that in a second. First thing we're going to do is figure out how to decide if something is a function or not. We learned about the vertical line test. We're going to practice that. But what if we don't have a graph, right? What if I just have points? Well, points can technically be graphed, right? You maybe haven't done it in a little while. We will soon. But points can technically be graphed. Now, you don't always have like a nice piece of graph paper sitting around, right? So how can you figure it out without the vertical line test? Well, what you want to do is to figure out if something is a function or not, you want to look for repeating x's. Okay. If an x value happens more than once, the graph is not a function, because if you were to plot all the little points, something would end up kind of like laying on top of something else in a way that if you put your vertical line, it's just not going to work. Okay. So if you take a look at example 1 here, these are all little coordinate points. Remember, when you have a coordinate point, this first number is your x and this second number is your y. So for each one of these, the first one is an x, the second one's a y. Okay? So all we need to really look at right now is just our x values. So this first point has an x value of -2. This next one has an x value of -1. And then we have 0. Then we have 1. And then we have 2. Alex. The y values repeat, right? Yeah. We have a -2, a -1, a 0, a 1, and a 2. Are all of those different numbers? Yeah. We're ignoring the y's for now, right? Don't worry about the y's. Just look at the x's. -2, -1, 0, 1, and 2. Are all of those different? Yeah. So nothing here repeats. So we would just say that this is a function. So function. And something you're going to be asked to do is explain or like pick out a proper explanation. So we're going to say function, because now there's a few different ways you could say this. You could say function because none of the x's repeat. That's one way some people say it. But like the proper like mathematical way to say it is that it's a function because every input has one output. Because every x had just exactly one y, none of your x's repeated. All right, let's look at part 2 then. Remember, your first number in your parentheses is your x and then your y. So in this one, what's your first x value? 4. Then what do we have? 8. You guys can just say it. Then what's next? 6, then 4, then 5. In this one, do any of my x's repeat? Yeah, which one? The 4. Yeah, I have the same value here and there. Okay, so do I have repeating x's? Yeah, if I have repeating x's, can it be a function? No. So we're going to say for this one, not a function. And that's because we would say 4 has multiple outputs. Because what coordinate points technically are, guys, is they're all associated with an equation. We don't have the equation right now. But what this actually means is if you take this certain equation, whatever it is, doesn't matter, and you plug 4 in, you could get 0, but you could also plug 4 in and get 3. And you don't want to be able to get more than one number. Okay? Okay. 3 and 4 are the exact same thing, except it's not set up as points. It's set up in like a sideways T-chart type of situation, okay? So it lists all your inputs or your x's at the top, y's or outputs at the bottom. Okay, so these are your x's and then your y's. So let's look at our x's again. We have 0, 1, 3, 2, and 1. Do we have any repeating x values? Yeah, which one? 1. Yeah, 1 repeats. Okay, so is it a function? No, not a function. So, not a function. Because 1 has multiple outputs. Good. All right. So number 4. Take a look at number 4. Our inputs are 0, 1, 2, 3, and 4. Any repeating x's there? No. So what can we say? It is a function, and we can just put the exact same reason we did in number 1. So this is a function. Every input has 1 output. So when you're asked for an explanation on your homework, guys, you don't need to guess. Just come back and copy the one that is appropriate for the example that you're doing, okay? And if you guys need me to zoom in at all, let me know. All right. We got that copied? Excellent. All right, number 5. This one is, again, a little bit different. This is kind of done as what we call a like a flow chart, okay? So here your inputs or your x's are in this first circle. So our inputs are -1, 3, and 11. Our outputs are 4 and 15. Now something you might notice, aren't there 3 inputs but only 2 outputs? So with these, you got to pay attention to the arrows. This is saying if you plug in -1, 4 is going to come out. This is saying if you plug in 3, 15 is going to come out. And if you plug in 11, 15 is going to come out. So if you take a look, doesn't each x only have one little arrow coming off of it? Right? -1 only has one little arrow coming off of it. 3 has one little arrow. 11 has one little arrow. So that means they only happen one time. So this one would be a function. That's how you read that kind of graph. Because then if you look at number 6, you just have the number 1/2, right? And doesn't it have 3 different arrows coming off of it? So that means that means 1/2 is technically happening 3 times. So for number 5, we're going to say function. And then what's our reason we can say when it's a function? You can look. Yeah, every input has one output. Good. And you can always say that if it's a situation where you're given like values, like points or a t-chart or something. All right. Take a look at number 6. Now with this one, again, I already kind of talked about it, but isn't 1/2 going to -2 and to 0 and to 4? So how you kind of have to read that is since there's 3 different arrows coming off of it, it happens 3 different times. So this one we would say not a function. And we would say because 1/2 has multiple outputs. Questions about those ones so far? For which one? Oh, number 5 and 6? Oh, yeah. Okay, so so think of this, it's kind of like a T-chart in a way, Alex, except it's not, like everything's not like lined up and listed out. So in number 5, -1 has 1 arrow, right? And it goes to 4. 3 has 1 arrow and it goes to 15. 11 has 1 arrow and it also goes to 15. That, since each one only has 1 arrow coming off of it, it only happens 1 time. So none of them repeat. Does that kind of make sense? Okay. And then if you look at number 6, how many arrows is coming off of 1/2? 3. So how many times is it happening? 3. So that means that number repeats 3 times. Does that help a little bit? Okay. No, yeah, you're fine. I don't mind repeating. All right, number 7. Jaden already gave us this one. So this is a little different. This one we don't have points, right, or a T-chart or anything like that. We have a picture. And if you look up at the top of your notes, what can we use if we have a picture? What little visual test can we do? Jake? The vertical line test. So what that means again is if you draw a vertical line anywhere in this picture, it needs to go through it only 1 time if it's a function. So if I draw a vertical line anywhere I want through this, how many times is it going to go through your picture? Twice. Once at the top, once at the bottom. So would a circle be a function? No. And this one, our explanation's a little different because it's a picture. We would say not a function because it doesn't pass the vertical line test. All right. Take a look then at number 8. Draw a vertical line through it. Anywhere you want through it. How many times is it going to go through this graph? Just once, yeah. Just 1 time. So, would number 8 be a function? Yes. And then for this one, we would say it does pass the vertical line test. So function, it does pass the vertical line test. Good. All right. All right, I want to at least start the back and then see where we are and see if we need a break. We got started a little late though, so we'll see today. I'm not sure yet. All right, finding domain and range. So finding domain and range from the front, we wrote down domain is all your X values, range is all your Y values. So again, this is, you got to think of this like in a graph. You have your x-axis from left to right. You have your y-axis up and down, right? So for your domain, it's all the full distance that your graph could go from left to right. And for your range, it's all the places it could go up and down. If I give you individual points, like little coordinates or a T-chart or something like I did on the front, what we do is we make a list. Because our points, if we just have points, they don't connect. They're just little individual points. So we're going to make a list of our values for that. But if we have a line or a curve, doesn't a line or a curve actually just like, isn't it continuous, right? So for those, we can't make a little list because there's all those other little numbers in between, like decimals and fractions and stuff. So what we do for these is we write an inequality. Okay. So if it's one where you need to write a list, it would look something like this. You would say domain, or you could just put a capital D, whichever you prefer. And you do, I'm not very good at them, especially in this little, on this computer, but you know those little squiggly parentheses? That's technically what you do. They look like this, kind of. Squiggle parenthesis, and then range. I'm not expecting it to be beautiful here, except I really can't do it on this computer. Squiggle parenthesis, it's just not sensitive enough. They look like this. So you would do domain, and then it's like a squiggle parenthesis, and then another squiggle parenthesis, and then range, squiggle parenthesis, and you like list out numbers in here. I'll show you in a second. Okay. And then if we're doing it as an inequality, it's continuous, right? So what you would do for your X values, you would put in, I kind of like to do these. I think you guys have realized I like to do little fill in the blank type things, right? So if it's an inequality for your X's, I'm going to put a blank, then a less than sign, an X, and then another less than, and then a blank. And you would put your lowest number on the left and your highest number in the blank on the right. And then if it was for your Y values for your range, you would do the same thing, except with your Y, like this. You'd put your lowest Y value on the left and then your highest Y value on the right. All right. It works better if you just try it out. It's kind of a confusing thing to explain. You got to see one. So if you take a look at number one, is this a list of individual points or is this a line or a curve? Number one. This is a list, right? This is just individual points. If it's individual points, we are going to make a list. Yeah. So we have individual points. We are going to make a list. I don't care if you just put D for domain and R for range, or if you write out domain and range. Okay, it's up to you. For today, since I want to make sure we remember our words, I'm going to write it out. So domain, and then I'm going to put a little colon, and then range. So what we're going to do is simply make a list. Remember, in a coordinate point, this first number is your X and then your Y, right? My domain is just a list of every single x value. So if I take a look at my points, all I want to do first is go through and identify all my x values. So that's all of the like first little numbers. So -5 is an x value. Then look at the next set of parentheses. 0 is an x value. Then look at your next set. What's your x value? 2. Then look at the next set. What's your x value? 5. And then all you got to do is write them out as a list. So I'm going to put my weird little squiggly parentheses. Just do the best you can with them. I'm not that worried about it. And I'm going to simply list those numbers. -5, 0, 2, and 5. And then I'm done with my domain. And that's all that takes for that one. All right, now take a look at your y's. What's my first y value? 0. What's my next y value? 1. Then what? 3. Then what? 10. So then for my range, all I have to do is list out those. 0, 1, 3, and 10. Not too crazy, right? Okay, try it out with number 4, the one right below it, because it's the exact same thing, right? Just some different numbers. So try it out with number 4. Domain. Who can tell me what my x values were for this? Jake. Yep, what else? Yep, 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 absolutely. And then just list them out. Right, -2, 0, 3, 7. Good. Dallas, what about my range? Yeah. 0, 4, 5, and 6. Absolutely. If you missed one, fix it. Also, guys, if you're ever doing one and a number repeats, you can always just write it multiple times. That's okay. All right. Okay, so now we feel okay about that one? It's pretty easy. All right, so now take a look at 2, and then 2 and 5 will be the same. 2, it's on a graph, right? But are my points connected? No. So technically, they're just points. They're just written a different way. So if they're points, are we going to write a list or do an inequality? A list. Now, what makes this one a little bit trickier is, again, your points aren't like written down for you, they're graphed. But could we use our graph to figure out what each point is, like as an X and Y? Yes, I highly recommend that you write all these down first. 80% of the time, if you just try to go purely based off the picture, you're going to miss one, read a number wrong, make a mistake at some point, okay? So we are going to just go through and we're going to write down what each coordinate point is. So here's this first one. Ooh, I shouldn't do it in blue though, because my graph is in blue. Okay. Now, this is a good refresher too on how to read a graph and your coordinate point. Remember coordinate points? It's an X value and then a Y value, right? Please don't tell me it died. Okay, good. All right, so it's an X value and then a Y value. Your X is left to right. Your Y is up and down. You always want to read your X first and your Y second. And you always want to start from what's called the origin, which is 0, 0, right? Where your two little X's cross. So if I'm going to, and I like to just go from left to right. So I'm going to pick the point all the way on the left, which is this one I highlighted in yellow. So if I start at 0, 0, to get here, I go left 1, 2, 3 units, right? Does that make sense, guys? Okay. So that means when I write down this coordinate point, since I went left 3 units, my x is going to be -3. And I know probably some of you are like, yeah, I remember this. And some of you probably are like, I don't remember this. And that's okay. All right, then from there, I went down 1, 2. So if you go down 2 units, that means your y value would be -2. Sorry, I'm not good at drawing 3s with a stylus for some reason. It's my most challenging number. Okay. So this means if you see the point -3, -2, that means from your origin, you went left 3 and down 2. All right, let's go to the next one. This one here. Okay. So for that one, from 0, 0 again, do I go left or right? Left. How many units? Just 1. So that means my x is -1 because I went left 1 unit. Left is a negative direction, down is a negative direction. Right is a positive direction, up is a positive direction. And then from there, wasn't I already on my point? So did I have to go up or down at all? So if I don't go up or down at all, that would just be then 0, exactly. All right. Then, again, now I'm over here at this point. I just keep going over to the right. So now from 0, 0, do I go left or right to get to my next one? Right. I go right how many? 1. Yeah, so my x is 1. And then do I go up or down? Up. How many? 2. 1, 2. So that's 1, 2. Do we see why we should write these down? What's up, Lon? Okay. All right, now for this next one, we're over here. So from 0, 0, do I go left or right? Right. 1, 2, 3 units. And then from there, I go up 1, 2, 3, 4 units. So that's 3, 4. All right. So now it looks the same as number 1 did, doesn't it? So now can I just do the same thing? Yeah. Would it be really hard though to list out those, like to do your list if you didn't write all these down first? Probably. Okay, I don't recommend it. But now we can just do the same thing. So remember your domain is all your x values, which is all your ones in the front. So that would be -3, -1, 1, and 3. So in your curly parentheses, -3, -1, 1, and 3. That's just the certain kind that they are for this kind of thing. Because there's other kinds that you use in other notation. This just happens to be what the math people have decided. All right, so then for range, and you don't want to use, the real important thing, Bailey, is you don't use the rounded ones because the rounded ones are used for coordinate points, right? Okay, so now for your range, which numbers would we list in our range? The ones on the right side. Olivia, what do you think I should write down? Exactly. -2, 0, 2, and 4. Over these. If you wrote down a point wrong, please make sure you fix it. No point in having wrong things written down. All right. Lynn, what was this first coordinate point? This one here. Oh, that's okay. It goes right 1, right, and then up 2. So how would we write right 1 up 2 as a coordinate point? Yeah, 1, 2. 1, comma, 2. Dallas, what else do we have? Yeah, 2, 6. Good. Alex, what else do we have? Yeah, 3, 3. Asia, what else do we have? Yeah, 4, 5. Oh, wait. I think it's, no, we don't have 4, 5. We have 4, 2. Do you see that one, Asia? I don't know. Oh, wait, you wrote 4, 5. There's 5, 4. You just wrote it backwards. 5, 4 is one of them. But yeah, next would be 4, 2. It doesn't really matter if you wrote them in order or not, as long as they all show up. Yeah, but 5, 4 would be one. And then I think that's it, right? Always go back and double check and count them. Like you have 5 points, you should have 5 points written down. And then let's write our domain and range as our list. So domain, Hannah, what did you write for your domain? Yep, 4 and 5. Good. And then range, Aaron, what did you write as your range? Yeah, 2, 6, 3, 2, 4. Could you have reordered this so that it was in from least to greatest? Yes. If it's multiple choice, that's probably how it's going to be written. Yeah, tends to go from least to greatest, but it's not a big deal. All right, questions on that one? People at home, questions on that one? Okay. All right, and then number 3 and 6. 3 and 6. Now this one, this is a continuous like line or curve, right? It doesn't end up stopping. But everything's connected. So if it's connected, do we do a list or an inequality? An inequality. So here's what I recommend you do for this. Now we just finished our inequality chapter. If Hayden, have you done inequalities before? Like less than, greater than? Okay, perfect. We just finished it. So if you have a question about any of the signs, let me know. Okay. So here's what I would do. Big fan of the fill in the blanks here. My recommendation is to put your domain, right? Then your range. And we're going to make ourselves little fill in the blanks. Now, domain is all your x values. So I'm going to put a blank and then my x value and then another blank. Now I'm going to figure out my inequality signs. Well, do I have open circles or closed circles? Closed circles. What, do you guys remember what kind of signs I could use if it was closed circles? Yeah, greater than or equal to or less than or equal to. Now to keep our lives simple here, we're going to always go from least to greatest. So your smallest number is going to go on the left. Your biggest number is going to go on the right. So you're always going to use less than or equal to signs or less than signs if they were open circles, okay? Just that way it's a nice little, just an order for you to write things in, right? You'll have your least number and then either a less than or equal to or a less than sign, depending on if it's open or closed. Then your x, and then the same thing on the right. Then for your y's, we're going to do the exact same thing because, again, still closed circles, right? We're going to go from least to greatest. Jaden, are you in there? You sit up for me? Maybe grab a pencil. Pretend like you're going to do something at least. Thanks. All right. So put your blank less than or equal to y less than or equal to blank. That was a bad inequality symbol. There we go. Fixed it. All right. So now the question is, now this part, you should always just write it down, right? But now we got to figure out our numbers. Now, if you look at your graph, it extends, right? It all connects. So we need to figure out what our smallest x value is and what our biggest x value is, because your domain is all the places your graph reaches from left to right. Now, so what I want you guys to then do is look all the way to the left of your graph. Just start all the way towards the left. Does your graph start where the -3 is? Like if you look at the -3, is your graph there? Is there any like line or dot or anything at -3? No. What if I went over to -1? Has it started at that point? Right here? Yeah, oh yeah, what did I say? Did I say -3? Oh, did I say -1? I meant to say -3. Yeah, if you look right here, at that point, actually I'm going to do this with a highlighter. It's a little easier to see. So if you look right here, isn't that actually where your first dot is? Yeah. It doesn't matter that it's not on like your axis. That's okay. But that's kind of just in general where it starts. Then just keep going in that direction. At -1, your graph is still going, right? At 0, your graph is still going. At +1, your graph is still going. At 2, your graph is still going. At 3, your graph is still going. At 4, is your graph still going? No, where did it stop? At 3. Right here. After that, there's nothing else on the left or right, is there? Nope. So that means your smallest number on your range is kind of like where your graph starts. It started at -2. And then it went to the right, went to the right, went to the right, went to the right until it hit 3, and then it stopped. This one is one that takes a couple to practice, okay? So if you're a little confused right now, that's normal. Now let's look at your range. You're going to do the same thing, except range goes from bottom to top. So now let's look at your graph all the way down here. Has your graph started yet? You're looking at it like this way now. So has our graph started yet? No. At -2, has our graph started yet? At -1, does our graph start? Yeah, right here. It kind of starts like here, right? And then, do we still have graph going on when we hit 0? Yeah, it goes up and up and up until we reach what number? 2. It's almost like finding what little box your graph fits into, okay? So from bottom to top, your graph goes from -1 to 2. So -1 is what would go on the left, and then 2 is what would go on the right. Again, this one takes a couple to practice to really figure it out. Yeah, go ahead. All right, and now take a look at number 6. All right, so this one, it continues, right? So this one we're going to write an inequality for, so let's just follow our same steps, right? D for domain. So for this one, though, don't we have one open circle and one closed circle? Yeah, what do you think we would use for our open circle? Less than. So what we're going to do is you're going to put your less than sign, your X, and then a less than or equal to sign, because we had an open circle, and then where it ends, it's a closed circle. Does that kind of make sense, guys? Where your graph starts, it's an open circle. Where your graph ends, it's a closed circle. So less than or equal to. Then for your range, again, range goes from bottom to top. So where your graph starts at the bottom, it's a open circle. So you would use less than. And where it ends at the top, it is a closed circle. All right. So now let's take a look at our numbers. So left to right. Take a look at the left. What number on the from left to right do you think your graph starts on? Any ideas? Yeah, 0. If you take a look at -1, is it at -1 yet? No, but once you hit 0, doesn't your graph kind of start happening? Yeah, right here. And then, is it still happening at 1? What about at 2? What about at 3? What about at 4? No. So it ended at 3. So your domain is going to go from 0 to 3. And then for your range, you go from the bottom to the top. So go all the way down. At -1, do we have any graph yet? No, our first point happens here, right? Which would be what value? 0. And then it goes up at 1, and at 2, and at 3. Is it still happening at 4? No, so it ended at 3. Right? So 0, 2, 3. All right. And I know we're almost done. I want to look at just one more thing with you guys. Yeah, I know. And then we're not going to worry about this chart right now just because we don't have the time. But I do want to talk about independent versus dependent variables. Independent, if something's independent, it just kind of does its own thing, right? You guys, wait, what are you, wait, sit down, sit down, sit down. I'm talking, we're not just getting up and like putting things away. All right, so if a value is independent, it does its own thing, right? It's independent, does its own thing. But if something is dependent, doesn't it kind of rely on what everything else is doing? Okay. So when you're doing, when we're dealing with like especially word problems and stuff here, we have independent and dependent variables. Your x value is the independent because it changes the y, which is the dependent. Your x's are your inputs. They're what you're plugging in. You kind of get to pick them. You can kind of pick whatever x value you want. But your y depends on what happens when you plug in x. So x is independent, y is dependent. So if you look at example A here, it says the function y equals -3x plus 12 represents the amount y in fluid ounces of juice remaining in a bottle after you take x gulps. Identify the independent and dependent variables. Now, again, I already told you independent is x, right? And your dependent is y. Now, let's think about it in terms of this problem. This is like you have a bottle full of liquid, right? Each time you take a sip, what happens to that liquid? It goes down. What if you take a really big sip? What if you take a really little sip? So don't the sips you take affect the amount of liquid in the bottle? Don't you get to kind of decide how many sips you take? Yeah, that's why the number of what I called gulps in this problem, but that's why the gulps is x and the amount of liquid in the bottle is y, because your gulps affects the bottle or affects the liquid. So write down that the independent is x gulps and the dependent is y, and we'll put ounces. Okay, we don't have time for B. We had too much other stuff at the beginning. Okay.